Hello students, here is the second example. In this example, I will show you how to use contingency tables and how to use them to answer simple probability questions. The table below describes the distribution of a random sample of 100 individuals organized by gender and whether they are right or left-handed. Let's denote the event M is the subject is male, F is the subject is female, R the subject is right-handed, L the subject is left-handed. We want to compute the following probabilities. Before we start computing the probabilities, let me explain this contingency table. So basically we have four categories that we organized our subjects to, or the individuals in the survey to, or experiment. We have males who are right-handed and we have males who are left-handed. So we have 43 males who are right-handed and we have 9 males who are left-handed. And then we have 44 females who are right-handed and we have 4 females who are left-handed out of the 100 individuals. That means if you add all of these numbers, you're going to end up with 100 individuals. Now that we organized our individuals into categories like that, the first thing I like to do is to find the individuals in each category by itself. So meaning first I will find the individuals in the category of males. How many males are in total we have in this survey? So I'm going to add 43 plus 9. I will get 52. And then I will find how many females we have in this survey. That is 44 plus 4, which is 48. Now, this should add up to 100 because that is the total number of males and females in this study. Now, we can find other categories. We can find the sum of other categories. For example, I can figure out how many right-handed people are there in the survey by adding 43 plus 44, which is 87. So 87 people are right-handed. And then I can find how many people are left-handed in this study. And I can find 13 people are left-handed in this study. Now I can answer those questions. So the first question says, what is the probability of M? Meaning, what is the probability of selecting a male? If you're selecting an individual, what is the probability that you're going to select a male? That is, how many males in this survey to select from out of how many total people I am selecting from? I'm selecting from the total of 100 people. In how many ways I can select males? I have 52 chances of selecting a male because that is how many males there are. Then the next question says, what is the probability of a female? So the probability of female is how many females I have to select from. I have 48 females out of how many people I am selecting in total? Out of 100 people in total. Meaning, if I am selecting from the 100 people that I have, the chances of selecting a female is 48 because that is the number of females I have. Now, the next question, what is the probability of selecting a right-handed person? How many right-handed people we have in the survey? We have a total of 87 right-handed people that we can select out of the 100 individuals that we have. Next, what is the probability of selecting a left-handed person? We have 13 left-handed people to select from out of the 100 people that we have. So each of these, remember that we can represent them as percentages. So this is 13% only. Next, we will find what is the probability of selecting a male and right-handed. What is the probability that we want to select a male who is right-handed? Let me show you how the contingency table is going to help us with that. So they have to fulfill both of these conditions. The person that we select must be a male and right-handed. And those people are 43 people only out of the 100. So 43 will fulfill that out of the 100 people that we have. So as you can see, this made the computation a lot simpler than if we are dealing with raw numbers. The next probability is what is the probability that we're selecting a female and left-handed. So how many females are left-handed in this survey? We have 4 females who are left-handed. So the answer to that question will be we have the choice of to choose from 4 out of the 100, or we have to select from we can select 4 females who are left-handed out of the 100. Next, we want to find the probability of male or female. So this basically tells us what is the probability of selecting a male or female. The number of males and females are 52 plus 48, which is 100 out of 100. So the probability is 100% or equal to 1. We are sure to select either a male or a female out of these individuals. That is an event that must happen. Next, we will find the probability of selecting a male or right-handed. So to compute that, let me show you on the contingency table how this is going to help us. So let me erase all of these. The probability we're looking at is, what is the probability of male or right-handed? Probability of male or right-handed. So we're selecting from the group of males. We're selecting from the group of males, and we're selecting from right-handed people. So this group is all of the right-handed people without repetition, and that will give us 43 plus 44 plus 9. So the answer is going to be, it's going to be 96. It's going to be 96 out of 100. Next, we will find the probability of selecting a female or left-handed. Remember, again, when we have an or event, that means all of the events that are either in the first event or the second event or in both of them without repetition. That means we're looking at all of the females, all of the left-handed people, even the ones who are females without repeating that. So let me highlight the group. So I'm looking at all of the females or the left-handed people, including the females. So I'm not going to repeat the 4 twice because I will be double counting. In this case, this will be 9 plus 4, 13 plus 44, which is 57. So I have 57 subjects or individuals in that group out of the 100 to choose from. Next, we will find the probability of the complement of males. So the complement of males is basically the rest of the individuals in the sample space that are not males. So 100 minus 52 is 48. I have 48 out of 100. Basically, this is the probability of selecting a female, just like we computed previously. The next probability that we want to work on is the probability of selecting. What is the probability of selecting a right-handed person, given that that right-handed person is a male? So in this case, we have to restrict our sample space to the male group only. I am going to highlight the male group. I have, this is the male group, which has 52 subjects or individuals. And how many out of these are right-handed? I have 43 right-handed people out of the 52. So given that we're only talking about the males, how many people are right-handed? Or what is the probability of selected right-handed person? That is a 43 right-handed males out of the 52 in total. Now, what is the probability of selecting a female given that they are left-handed? So in this case, I will select the group again that I want to restrict my sample space to. Remember that I am restricting my sample space only to left-handed people because that is the condition. Given that we're only talking about left-handed people, what is the probability of selecting a female? The group of females in that category are 4. I have 4 females out of the total of 13 in that specific category. The last probability that I want to compute is what is the probability of selecting a left-handed person if we are given that they are female. So now we're going to restrict our sample space to only the female group, meaning that we're only looking at the category of females only. And now, what is the probability of selecting a left-handed person out of the females? We have 4 left-handed people out of the total of 48 females that we have. So this is how you're going to use contingency tables in order to help you compute probabilities. I hope this explained how to do that, and I will see you in a different example.